Okay, class, today we're going to look at a new way of identifying a point in space. We're probably all accustomed with what we call the Cartesian or the rectangular coordinate system, where we have x as our horizontal axis and y as our vertical axis. And then we go out some distance on the x-axis to get the first coordinate. So we'll call this x1. And then from there we go in a vertical distance, we call that y1. Then the point that creates is, not surprisingly, x1, y1. Okay, a new idea with polar coordinates is we're going to take this notion of a pole, and you can think of the pole for now as like where the x and y axis meet. So the pole, maybe think of it for now as like 0, 0 in the coordinate plane. And then the polar axis is going to coincide with the x-axis. Okay, so we got a pole and a polar axis, and the other thing we need to create the point, instead of x1, y1, we're going to use an r, which is a distance. You can think of it kind of like a radius, and a theta, which is an angle that we move from the polar axis. So I'm going to go if I create an angle that matches theta, and then it reaches out a distance of r. So think of it as like the radius of a circle, where the point at the end of the ray here is on the circle, and if we go out this angle theta, it defines a point where we meet called r theta. Alright, so if we match the pole with the origin and the polar axis with the x-axis, what we would call the point xp,yp would be equivalent in this scenario to what we would call the radius length, or the length, followed by the angle theta in polar. So this is Cartesian, equivalent in polar. Alright, let's explore a little bit with the points on the unit circle, and let's come up with their equivalent polar coordinate. Okay, so all of these points on the unit circle help give us the sine, or the trigonometric function, sine, cosine, and tangent. But we can also take a look at this, and if I've got the square root of 2 over 2 for both my x and my y, then what would the polar coordinates be? So this is ordered pair on a Cartesian plane. What is our r theta? Well, we call this the unit circle because the radius is locked in at 1. So we're definitely going to have a radius of 1 in this case. And then since it's the angle 45 degrees that takes us through that point, or up to that point, our theta is going to be 45 degrees. Or if we wanted to use radians, it would be 1 comma pi over 4. Alright, let's come over here and let's take a look at what would 7 pi over 6 on the unit circle. We know that its coordinates are negative square root of 3 over 2 for x, negative 1/2 for y. So what would the polar coordinates be? Well, we're going to take this and we're going to write two different ways we could actually do that. We can say let's use a theta that reaches over here. Okay, and we know that that is 210 degrees, or 7 pi over 6 radians. I kind of locked that degree mark, but remember that's 210 degrees. So we know our radius is 1, and if we wrap 210 degrees, we're there. We're at this same place. Okay, so these are all equivalent. These are equivalent. There's another way to do this, though. What if instead I said, hey, I want to go -1. -1 from the pole would be 1 unit from the pole. So if I said let's go -1, then what angle do I have to wrap to if I go a negative distance? Well, if I go a positive distance, it takes me up here to the pi/6. Okay, but if I go the opposite direction, it takes me down here. So if I indicate pi/6 for the theta, and I want to get to this point, I have to go a distance of -1. So we could also say -1 and 30 degrees. And that would also take us to the same place. In terms of radians, it would be 1 and the 210 is 7 pi/6. If I go -1, then it's pi/6. All right, so these all represent the same location as well. Okay, so it's probably worth mentioning that if I'm using rectangular coordinates, I've got a single choice on how to locate that position. So that's powerful and nice, but this is nice as well because it's flexible, because I have more than one option to locate the same point in space. Okay, so let's take this and create a location for the point -3 2 pi/3. All right, so I can take a look at the angle 2 pi/3, and I know that that's going to take me same as 120 degrees up here. So there's my terminal side. Now instead of going 3 units positive direction, once I get there, I have to go 3 units in the negative direction. So I'm going to take it in the opposite direction as this. So we're going to take it through the line in this direction. Now remember, that's the origin, so that's only 1, so I got to go 2 more of these distances. So I'm just going to kind of eyeball it. And here's 1 more radius. So there's a radius of 1. About here would be a radius of 2. So then I got to go 1 more of those in that same direction. It's going to put me about right here. Okay, so this would be distance of -3 from the terminal side created by 2 pi/3. Now what I want to do is identify this point with a positive radius. So if I identify the same point with a positive radius, then let's put the 3 in there. But I have to get to the terminal side that's instantiated here. Okay, and then I'll go the positive direction from that angle. That angle is 5 pi/3. Okay, so those are equivalent. One more thing I could do, keep it positive, is identify the angle in a negative direction. So that would be -pi/3.